Welcome to this lecture on artificial neural networks, multi-layer artificial neural networks. So in this particular lecture, we will see how to solve non-linear problems by using artificial neural network, that is multi-layer artificial neural networks. So what do I mean by a non-linear problem? You can see over here is the truth table for XOR gate, all right, and I have plotted the same over here, all right. This one shows the plotting of the XOR gate, all right, and what the characteristics of this is such that if I draw a line, okay, in any way, all right, if you try to draw a line, okay, in any way, all right, there is no instance, no line which can divide our solution space in such a way that all the zeros are on one side and all the ones are on the other side, okay. Whichever line you use, be it horizontal, vertical, or this slanting line, okay, you'll always see that one instance of one is on the other side, okay. And what we want is something like this, okay. That is when we draw a line over here, okay. Sorry, I think a line, say a line from here, okay, such a line, okay. So this line is able to divide our problem space in such a way that all the ones are on other side and all the zeros are on other side. But this solution space, what we have over here, we have actually modified it, okay. So how do we get to that position, okay? How do we acquire that is uh, what is shown over here, okay. So in multi-layer artificial neural networks, we use more than one layer, okay, of neurons. And now the activation function, as was the square that was there, is now written inside, okay. So we use ReLU activation function over here. A ReLU function basically is maximum of 0 or whatever the term is, okay. So if we have negative values, it will be converted to 0. If we have positive values, those won't be touched, okay. That is what we mean by ReLU when we say that it is maximum of 0 or the X, okay. So what we take as our architecture to solve this XOR problem is that there are two inputs, two weights associated with those inputs. The Of course, as it is with in every case, the sum of products will be performed, after which we will pass it through the ReLU function, okay. All the negative values will be converted to 0, all the positive values will be as it is. That is called as the Z, which is the intermediate output, okay. And that along with the summation function in the next uh, layer, I'm so sorry, I forgot to include bias over here, okay. So there will be bias over here as well, okay. It will be small b, but let it be, all right. So basically we have bias 1, bias 2, all right. And our function looks something like this, all right. So this uh, inner part, okay, this inner part uh, is passed through, sorry, this inner part is something that represents the first neuron, all right. And that is wx plus b, whatever is the summation, what we always have, that with with passing of the ReLU function 0 comma the that particular value, we take it as z, and then the outermost, that is wt plus the second bias, okay. This is the second layer. So now we have our values. Let us consider that we have the solution space. How did I get to this point? You can refer to this particular book which is dot deeplearningmook.org. In the contents you will find this. In the sixth chapter there's the example of XOR. Okay, and here you will find that the entire explanation with the all the values that actually solve the problem. Okay, so to specify the solution, you see this solution is given over here. Okay, so I took the values from there, and then I solved it. Okay, by you putting all the values. So first is you calculate w into x, that is x into w. All right, you get this particular value. Then you add bias to it. All right, and that we got as this value. Then we have to pass it through the ReLU function, which basically converts this -1 to 0 and keeps the others as it is. Then we multiply the outer weight with that ReLU function or z. All right, and that gives us our actual value. And for since we also have the bias, we add the bias at the end, and which gives us our final output, which is equal to the y which we want. All right, so what has really happened over here? If you want, you can perform this entire thing and see that it actually holds true. All right, and what actually happens over here is that the ReLU function, uh, which is a crucial point of point where our function actually converts into the solution, that plays a major part. Okay, so this negative value is basically converted into 0. All right, and you can see when I plot this particular instance. Okay, this particular the output of ReLU function, that is 0 0. Let me just show you. It's 0 0. Then we have two instances of 1 0, and then one instance of 2 comma 1. Okay, so this what it does is it converts all the negative values. We had 0 minus 1, so it would be somewhere over here. All right, so what it did was it converted it into a positive value. Okay, and converted into it to 0 0. Okay, so the value which would have otherwise been over here somewhere, okay, it is shifted to 0 0. Okay, and that is why now that our solution space looks something like this, where there are two values over here, one value over here and one value over here, and uh, the this value is the two values are of ones, and the outputs for the other two is 0. And when we draw a line from here to separate, okay, for example, if we write a line which separates this from this over here, we actually have a solution, and that is why the solution holds. Okay, that is why we got the solution. So that this is uh, an example of how non-linear non-linear problems are converted into linear and solved by multi-layer artificial neural networks. Okay, so if you did not get this part, please go through it again and again, what I'm trying to convey. Okay, this is basically folding of the entire solution, this input. Okay, we the input which was here, okay, now it has gone over here. All right, so that was regarding uh, how multi-layer artificial neural networks work. We will see back propagation in the next video. Thank you.